Hi there, this is Algebra 2, Chapter 3, Section 1A. In lieu, or not in lieu, but I guess trying to avoid making your video too long, this lesson we're actually going to split up into two parts. And so the first part is going to be, we are solving systems of equations. The first part will deal with tables and graphing, and the second part will deal with algebraic methods, which are substitution and elimination. The good news is that we've done systems of equations in Algebra 1. The bad news, that was probably a long time ago for most of you, and so maybe you don't remember everything. Sorry, I'm trying to kill these little fruit flies here. Don't mind me. But anywho, so basically a system of equations is when you have two or more equations with the same variables. And when you solve a system of equations, it's important to find the ordered pair. So the solution to a system of equations is an ordered pair, so you want an x and a y coordinate that satisfies all of the equations at the same time. Okay, so the first method that we're going to look at is to solve the system of equations by using a table. Okay, and so I want to give you guys a couple of pointers here. What you're going to do is, and maybe the easiest thing to do is to just go ahead and start. When you're solving a system of equations by using a table, you first want to write your equations into y equals mx plus b. So we're going to go ahead and do that. So I'm going to take my first equation here, my 3x plus 2. I'm going to subtract the 3x to the other side, meaning I'm going to get 2y equals negative 3x minus 2. Then I'm going to divide by 2 every single term, and I end up with y equals negative 3 halves x minus 1. I'm going to do the same thing with my second equation, only in a different color so we're not confused here. And we're going to add the 4x to both sides, and I'm going to get, let's not put it there, let's stay over here. We're going to get 5y equals 4x, because it's positive 4x, minus 28. Then I'm going to divide by the 5. And my final equation is y equals 4/5 x minus 28 fifths. Okay? And then we're going to use a table. And our table is not going to only have x, y. It's going to have x, y1, y2. Okay, so I'm going to put here y1, y2 because there's two y's. Okay, so here are going to be my x values, and because we want the ordered pairs to basically have the same y value, and that's going to be our answer. So, however, when you're doing a table, it's kind of hard sometimes to think of what number to pick. So I will say that it's always a good idea to pick numbers to get started with, to pick 0 and 1. 0 and 1 are always some good numbers to start with, okay? But what you're looking for is the difference between the values, okay? So when the difference between the y values is closer to 0, then that tells you that you want to pick a number that is greater than that value. Okay, so that might not make any sense right now, so let me just explain to you what I mean by that. So I'm going to go 0, I need my calculator here, where I put that. And it's okay for us to use decimals right now because we just need to evaluate the difference. So here we're going to do this. We're going to take negative 3 halves, which is negative 1.5, times 0, and then subtract 1. So we get negative 1. But when I plug 0 in to y2, I get 4/5 times 0 minus 28 fifths. And I get negative 5.6. See, there are two different y values. So I know right now that 0 is not the solution because I'm supposed to have the same y value for both equations, and I don't. But now I'm going to plug into 1, so I'm going to go negative 1.5 again, that's 3 halves. So negative 1.5 times 1 minus 1. And I get negative 2.5. Okay? And then for y2, I'm going to get 4 divided by 5, times that by 0, subtract, sorry, not by 0, I'm sorry. 4 divided by 5, and we're timesing that by 1. And then subtracting 28 fifths. And we get negative 4.8. Okay? Now, how do I find the difference? You always go y2 minus y1. So remember that when you go negative 5.6, I'm going to subtract negative 1. So when you subtract a negative, it's actually adding, okay? So just be careful there. Negative 5.6 minus negative 1, I get negative 4.6, okay? And then I'm going to do the same thing for the second value. So I'm going to get negative 4.8, and I'm going to subtract negative 2.5. So we're going to go negative 4.8, subtract negative 2.5, which again is subtracting a negative. And I get, excuse me, negative 2.3. So you see the difference between these two values is negative 4.6. The difference between the two y values is negative 4.6. But the difference between these two values is negative 2.3. So negative 2.3 is actually closer to 0. So that tells us that we should try a number after 1. If for some reason if these numbers were switched around, if the difference was closer to 0 at 0, for x equal to 0, then we would pick negative 1 next. Okay, so I'm going to say that again. You want to know the difference, and whichever one of these has the smaller difference, that tells you to either go larger or smaller. Okay, so if this number had been closer to 0 than this number, then we would have gone to negative 1. But since negative 2.3 is closer to 0 than negative 4.6, we're going to choose to go to the next biggest number, which is 2. And that is how I determined that I want to go to a 2. Okay, so now I'm going to try 2, and I'm going to go negative 1.5 times 2 is negative 3. I'm sorry, I didn't subtract the 1. Minus 1 is negative 4. So, negative 4. Awesome. Then I'm going to go 4 divided by 5 times that by 2. Subtract 28 fifths, and lo and behold, it's also negative 4. So in this case, the difference between the two values is 0. There is no difference. They're the same value. So we actually got lucky because we managed to find the solution without having to do more work. If for some reason this hadn't happened, we would keep trying to get the difference to be closer to 0 and choosing numbers until we got closer to 0. Another thing that I want to mention that didn't happen in this example particularly, but what if the answer is actually a fraction? Like what if I had picked 3 next, and then the actual answer is 2.5? Because that could happen. Well, in that case, again, you're looking at your difference, and anytime the differences change sign, in other words, like if this had been negative 4.6 and this had been positive 2.3, like the sign is different here, then that would also tell you that the number that you're looking for is in the middle, like in between 0 and 1. So just some information that you might want to have on hand is that whenever the difference between the y values changes sign, that means that the number is in between them. Okay, so, but in this case, our answer, our solution to the system is 2, negative 4. That is the ordered pair, x, y, that satisfies both equations at the same time. Alrighty, so now you're going to try these two examples again using tables, and then we'll go to the graphing method. Alrighty, now with the graphing method you kind of have some options, because if you're comfortable with hide and divide, then that's probably the easiest way to go. It's the way I'm going to go. But if you're not comfortable with hide and divide, then you're going to make more work for yourself, because you're going to have to take each of these equations and transform them into y equals mx plus b, just like we did in the last example. But I'm going to go ahead and use hide and divide. So that means that if I make x 0, I'm going to hide it. And that means I'm going to get negative y equals negative 1, so I divide by negative 1 on both sides, and then y equals positive 1. So that's my my y-intercept, and do the same thing with the y value. I hide the y value, which means I replace it with a 0, and then I get 2x equals -1. If I divide both sides by 2, then I get -1/2. Alrighty? And then for my second equation, do the same thing. I'm going to hide. Be careful here because they're trying to trick you. They put the x's and the y's in a different order, but I'm still going to hide the x, making it 0. And I've got 2y equals -16. And if I divide both sides by 2, I'm going to get -8. And then I'm going to hide the y. And I get -16/5. And that's an ugly number, but we are going to graph it anyway. Okay, so where is my ruler? Here we go. So 0, 1 is right here. X is 0, y is 1. And -1/2 0 is right about there. So here is my first line. I'll graph it in red to stay color-coded. Now it is very important when you graph, as we did like back in Algebra 1. If you have your graph off, like if you're making a really sloppy graph and you're not using a ruler, you might have these lines crossed in the wrong spot, and that would not be good. But just putting that out there. 0, -8 is down here. And -16/5. Well, 5 goes into 16 3 times, which is -15. So that's going to be 1, 2, 3, 4, 5. And then a little bit extra, because it's going to be an extra 1/5. So I'm going to put it right about there. Be as accurate as I can. Okay. And so now I have graphed the two equations. And what I am looking for when I am solving this little guy is I'm looking for the place where the two graphs intersect, and that'll tell me what the answer is to my problemo. Alright, so I'm going to try and check that now. And I can tell you right now that my graph is very off, because the answer is supposed to be -2, -3. And when I go -2, and here's -1, -2, -3, this is where the lines are supposed to be crossing. Okay? And you can tell clearly that that's not where they're crossing. Okay? So -2, -3 are supposed to be, and we can check that. Just want to make sure that I didn't do anything wrong here. I think the only problem that I'm having is that my graph is inconsistent. Some of the spacing between the values here is not the same all the way through, including on this axis. The spacing on the x-axis is smaller than the spacing on the y-axis, which is causing some distortion. You can see that I'm pretty close, but this is exactly what I'm talking to you about when you're making your graphs. I mean, it would be better for you to use graph paper. Obviously, I don't have graph paper available to me. But I do want to make sure that my graph is accurate. So I'm just going to make sure when I make x equals 0, negative divided by negative 1 is +1, y 0, negative divided by 2 is -1/2, x 0, and then -16 divided by 2 is -8. And then if I make y 0, -16 divided by 5, and -16 divided by 5 should be 5.2, -3.2, yeah. So that's where I did that wrong. So my bad. How sad, how unfortunate. So I drew this guy wrong. I don't know why I went to negative 5. I was getting really excited with the -16 divided by 5, but actually I said it out loud and then I didn't do it right on the graph. And maybe some of you caught that in the video, I don't know, but sorry about that. It's actually -16 divided by 5. 5 goes into 16 3 times, I said, with a remainder of 1. So it should be -3 1/5, and I went all the way to -5 1/5. I don't know, I think I was thinking 5 times 3 is 15. I don't know, but the problem is we're going to fix it. So we're going to go -1, -3, and it's supposed to be right here. Woohoo, at least I caught the mistake there. So now I am going to try and delete my mistake here. Ooh, that's going to be ugly. Pardon me while I fix my graph here, and I am so sorry about that. Don't shoot me, because that would be sad. Guessing would not have a mother. And let me try to fix this real quick here. I think that was -8. 1, 2, 3, 4, 5, 6. Okay, so again, we were at -8 and -3 and 1/5 is right about there. Maybe this time we'll have better luck, and it looks like we are going to have better luck. Look at that. Wow, made a huge difference there. Small little mistake that I made there and made a huge difference. Now you can actually see, if I can get this going for you. Wow, huge difference. So I had the wrong number there, and now that I have it, now you can actually say -2, -3 is a lot closer to the accurate value. So I apologize that again. And so the answer then is -2, -3. That is the ordered pair where the two lines cross. So when you're solving the system by graphing, just to refresh, you need to graph each equation separately and find the point where they cross. And that leads us to your do-it-yourself question, but more importantly, to this. Because we just said that when you're doing a system of equations by graphing, you graph the two lines and find where they cross. But we also know from before that it is possible to have two lines that never cross, which are parallel lines. And it's even possible to have two lines that are in fact the same line. And so what I want to show you here is basically how you can classify systems, because in the next example they're going to ask you to do that. So the first type is consistent and independent. That's what we call this little guy. This is what we just had in our example. We graphed two lines and they crossed in one point. So that's what we call intersecting lines, and there's one solution, the place where they cross. Then we have our next system, which is called consistent and dependent. And I try to do that. I don't want these to look like the third one. I kind of, I didn't want to graph them on top of each other because then you wouldn't see the two lines. So what I'm trying to show you here is that in the dependent case, the two lines are the exact same line. And so when you graph them, you're just going to really get one line. So same line, and then of course, where are they intersecting? They're always intersecting. So infinitely many solutions. And then of course, we have our inconsistent system, and that's the case of parallel lines where they never cross, and therefore there is no solution. So in our last example today, we are going to be asked to graph each system of equations and describe them as consistent and independent. That's one option. Consistent and dependent, or inconsistent. Okay, so again, I encourage you to use, when they're in standard form, these are in standard form. When they're in standard form, I encourage you to use hide and divide because it makes it a lot easier, but you don't have to. So here I go. I'm going to do hide and divide. X is 0. So 24 divided by 3 is 8. And then if y is 0, 24 divided by 4 is 6. Okay? For my other one, I'm going to get, if x is 0, 3, 0, which is 30, divided by 5 is 6. And if I make y 0, then 30 divided by -3 is -10. All right? And I can tell you right now that's going to be a problem, but we'll fix that in a second. Okay, so actually I guess we're going to do it now. So what I'm going to do here is I'm going to change my scale because I have to go all the way to 10 and 8, and I don't have those numbers on my axis. So that's a really easy fix. We're just going to go 2, 4, 6, 8, 10. So we'll make this 10. And we'll make this guy over here -10. Bam, fixed. Okay, so now to graph the line, the first line, I'm going to get 0, 8. So x is 0, y is 2, 4, 6, 8. And then 6, 0. So 2, 4, 6. I keep losing my ruler. Here it is. So we are going to graph that line just like so. And then for the red one, we're going to get 0, 6, which is x is 0, 2, 4, 6, and negative 10, 0, which is over here. And when I graph those two, there we go. So because these lines are actually crossing, this system is going to be consistent and independent. Where shall I write that? Over here. Consistent and independent. Basically, independent is when you have the two intersecting lines, and dependent is when you have the same line. So these are not the same line, and they're definitely crossing, so they're not inconsistent. So there you go. Now we're going to do part B, same way. Let's hope that my scale's okay this time. And I'm going to go, if x is 0, then y is 10 divided by 5, which is 2. And if y is 0, then I'm going to get 10 divided by negative 2, which is negative 5. Alrighty? So we have 0, 2, and negative 5, 0. For my second equation, I have if x is 0, then negative 20 divided by negative 10 is positive 2. And if y is 0, then I have negative 20 divided by positive 4, which is negative 5. So, I don't know about you, but you can already tell from right now that they have the same x and y intercepts. So I'm going to go 0, 2, negative 5, 0. I'm going to graph that line like so, all cool like. And then when I go to the red line, I'm going to go 0, 2 again, negative 5, 0. That's kind of redundant. You don't really have to graph it a second time. You can probably already tell that you got the same values. So they are the same line. So this system is, this is consistent, but not independent. It's dependent. Consistent and dependent. So our part A was consistent and independent, and our part B is consistent and dependent. And so now we're going to let you try these two, and then once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.